Okay. Yeah, so today we are going to solve the same problem again, but with a different approach. So we are going to use Floyd Warshall's algorithm, and he has a specific type of algorithm. The main concept is like um, introducing a middleman. So, for example, if we are taking path from 1 to 4, then we could take the path from 1 to 0 or 1 to 2 and 1 to 4. We can take it like this, right? So that's basically the concept of the whole concept of this. For example, if the path from 1 to 4 has a distance of 8, but a path from 1 to 2 and 2 to 4, 1 to 2 has 1 and 2 to 4 has 1, the total distance is 2. So we're going to consider this path, right? Not this path. So from 1 to 4, so we have this path as the optimum way, and we're going to use this path, and the minimum time required would be 2. So that's the same concept that we are going to use when solving this question. So initially, I'm going to initialize the adjacency matrix. So I'm going to use the adjacency matrix here, and I'm going to initialize with a float value, float of infinity. I cannot write today for some reason. Yeah, we have float of infinity for how many times we want to repeat this for. We want to repeat this for n times. Let me put this for I in range of n. So that should create as adjacency matrix. We can check that by printing out this one. Let's see. See that it printed out the matrix. Yeah, so now how do we solve this? So what we can do is let's assign the adjacency value vertices and edges with the distance, so that I'm gonna iterate over the times array, and here I'm gonna push in the u comma v, which would be the path, and with the distance that should update the distance, and what I'm also gonna do is the path that is required to visit 2 comma 2, which is this path itself, is 0. 3 comma 3 is 0, 4 comma 4 is 0, 1 comma 1 is 0. So I'm gonna update that as well. So for I in range of n, adjacency of I comma I would be equal to 0. Here you have to understand that the u, since we are only using n, the index would start at 0 instead of 1. So we have to minus 1 here because of that, because the index starts from 0 to n, right? 0 to n minus 1. So that's why we are negating 1 here. And now let's go to the core logic, which is pretty easy. So let me consider a mid position here, range of n, the same goes. So let me consider a I position. So these are 3 for loops. The complexity is not that great, but this is one way to solve the problem. And so we can say that for the adjacency of I comma j, we're gonna consider a minimum value here. The minimum value would be the value itself, and we're gonna use a mid over here, mid, So for example, you could go through the example here, like 0 and 0 would go to 0 0, and the mid, for example, if the mid is 1, so it goes to 0 and 1, and then and adjacency mid to j, so 1 to 0. So 0 to 1 and 1 to 0 would lead to 0, right? So that's one way to uh, arrive at the solution. So we're going to consider a minimum value of it, and that's pretty much it. So the minimum time would be the maximum of the adjacency of, so we have given k, right? So since it is 0 indexed, I'm gonna make it k minus 1, because we did the same over here as well. K minus 1 would give us a minimum time now, and yeah, I can print the adjacency matrix over here, and yeah, if the minimum time ever has a value of infinity, if minimum time has I'm gonna return the minimum time only if minimum time doesn't have the value of infinity, else I'm gonna return -1. So that should work. Let's see. Let's run the code here. You could see it compiled properly, and if I submit, it's gonna do the submit. Although the time complexity is really bad, but this is one way to solve the problem.